Hello friends and welcome back to my channel. In today's video, we'll be learning about the light chapter in physics. This is the part 1 of this chapter. This is a very interesting yet important chapter in physics. Before we start, let us have a look at what we'll be doing in today's video. We'll be learning about the speed of light in different mediums. We'll be learning about the definition and meaning of refraction of light, and also we'll be learning about some terms related to refraction of light. So first, let us learn about the speed of light in different mediums. For this, let's take three mediums which are air, water and glass. The speed of light in all these three mediums are different. So first, the speed of light in air. The speed of light in air is 3 × 10⁸ ms per minus 1. So the speed of light in air is the maximum. For this, you can either write 3 × 10⁸ m/s or ms per minus 1. Both the units are correct. Then we have water. The speed of light in water is 2.25 × 10⁸ ms per minus 1. The speed of light in water is less than in air, but it's more than in glass, because the speed of light in glass is 2 × 10⁸ ms per minus 1. So when we look at all these three different mediums, we can understand that the speed of light is maximum in air. Another very important concept is when the speed of light increases, the more optically rarer the medium becomes. For example, in this, the speed of light is maximum in air. So air is optically rarer than both water and glass, whereas glass is having the least speed. So glass is optically denser than air and water. Now if you look at water, water has more speed than glass. And the speed of light in water is less than in air. So water becomes optically denser than air and optically rarer than glass. So we can summarize that the speed of light, when it is more in a medium, it becomes optically rarer, and when the speed of light becomes less, it becomes optically denser. I hope this is clear. Next, let us learn about the refraction of light. Let us learn about the meaning and definition. So that definition is the change in the direction of path of light when it passes from one optically transparent medium to another is called refraction of light. Let us learn about this with respect to the picture. Now here, if this is the surface and AO is the incident ray, instead of moving in this slanting direction, which is straight towards the incident ray, our refracted ray is bending towards the normal. This change in the path of light from which it has to travel is called as refraction of light. So refraction of light occurs when a ray of light, which is the incident ray, travels from one medium to another medium. So when it passes from one transparent medium to another medium, the change in the path of light from which it should have traveled is called as the refracted ray. I hope this is clear. If not, you will understand more as we go ahead. Now, let us take three cases to understand this furthermore. First, when a ray of light travels from a rarer to denser medium, what happens? Let us learn about this with respect to this picture. Now, rarer medium, as we learned earlier, rarer medium over here is air and the denser medium here is glass. So when the ray of light, which is the incident ray, this is the surface and AO is the incident ray, instead of falling in this direction, it takes a bend towards the normal, if you see, which is OB. For more clarity, AO being the incident ray, it has to travel in this direction. But instead of that, it bends towards the normal as OB over here. So if N dash is the normal, the ray of light as refracted ray, it falls towards the normal, or rather it is bending towards the normal. This happens when the incident ray or the ray of light is falling from a rarer medium to a denser medium. I hope this is clear. Next, when a ray of light travels from a denser to a rarer medium, what happens? Let's learn about this with respect to this picture. Now here, let's take our denser medium as glass and our rarer medium as air. So here the incident ray is AO and it is falling on the surface. So when the incident ray AO falls on the surface, instead of moving in this direction, which is slant as per the incident ray, we see that it is moving away from the normal. Earlier it was bending towards the normal, but now here it bends away from the normal. This is because the ray of light travels from a denser medium to a rarer medium. So when a ray of light travels from denser to rarer medium, it goes away from the normal. So when this is the normal, instead of going in this way or bending towards the normal, it's bending away from the normal. So the distance between the normal and the refracted ray has increased over here. This is because the ray of light is traveling from an optically denser to an optically rarer medium. I hope this is clear. Next, let us look at what happens when a ray of light falls normally on a surface. Now, what do you mean by falls normally? Normally means 90 degree. Now, let us learn about this with respect to this diagram. So here, if this is our surface and this is the incident ray. Earlier we saw the incident ray was falling slanting or diagonally on the surface. Whereas here it falls normally. Normally is nothing but straight line forming 90 degree with the surface. So when it forms normally on the surface, that is when it's falling in a direction perpendicular on the surface, the refracted ray does not bend towards or away from the normal, rather it passes undeviated. There is no deviation, that is it does not slant away or towards the normal, but it goes in a straight line. It passes undeviated and it follows the path. There is no change in path of light, but it goes undeviated, separating the two media because it falls normally forming 90 degree. So this is what happens when a ray of light falls normally on a surface. Next, let's learn about some terms related to refraction of light. So time and again I've been saying incident ray, normal, refracted ray, etc. But what are all these? Let's learn about them in detail. First, we have our incident ray. Incident ray is nothing but the ray of light falling on the surface separating the two media is called incident ray. Now in this diagram, if this is the surface and this is the incident ray. Incident ray is the ray of light that is falling on the surface at the point of the normal. So if this is the normal, this is the incident ray which is falling at this point on the normal and it separates the two media. This ray of light that falls on the surface is called as the incident ray. Next, the refracted ray. Refracted ray is the ray of light traveling in the other medium in the changed direction is called as refracted ray. Here, when the incident ray falls, the refracted ray should fall underneath. So here, instead of going in this direction, it will fall either towards the normal or away from the normal. That ray of light which passes in the other medium. So we've already learned that refraction occurs when the ray of light travels from one optically transparent medium to another, the change in the direction. So when it's falling from one medium to another, the change in the direction of path of light either towards the normal or away from the normal, that is called as the refracted ray. Normal. Normal is the perpendicular drawn on the surface. So here normal we can see is this, and it's 90 degree over here with the surface. So the perpendicular drawn on the surface separating the two media at the point where the incident ray strikes it is called as the normal. So in this diagram, this is the normal. Normal is nothing but it's an imaginary perpendicular drawn on the surface. It separates the two media and it's the point at which the incident ray comes and strikes the surface. This is called the normal. Normal is always 90 degree. Now, next let's learn about the refracted ray. Refracted ray is nothing but the ray between the normal and the refracted ray. That is called as the angle of refraction. Next, let's learn about the angle of incidence. Angle of incidence is nothing but the angle which is formed between the incident ray and the normal. This angle is called as angle of incidence. So if angle of incidence is the angle between the normal and the incident ray, the angle of reflection is the angle between the normal and the reflected ray. Reflected ray is nothing but when the incident ray strikes the surface, the ray of light that bounces, that gets reflected, that bounces back is called as the reflected ray. So angle of incidence is always equal to the angle of reflection. For example, let me tell you, we already know that the normal forms 90 degree. So when the normal forms 90 degree and let's say the angle of reflection is 45. So then in that case, even the angle of incidence is also 45. Or if I say the angle of reflection is 30, then the angle of incidence is also 30. So in that case, since this is 90 and angle of incidence is refraction is 30, the angle formed over here will be equal to 90 minus 30, which is 60. So if this is 60, that means this is also 60 and this is 30 and this is 30. So that's how it is. When does this happen? When there's an angle of incidence and angle of reflection. Whereas the angle of incidence and angle of refraction are not always same, but angle of incidence and angle of reflection are always same, and it forms 90 degree with the normal and the surface. So that's all we need to understand about this. Now let me make it more clear for you using two illustrations. Now let's take this surface X and Y. So X and Y is our surface here, and there's a ray of light that's falling on the surface, which is nothing but our incident ray. So when this is our surface, the ray of light that falls on the surface separating the two media is called as our incident ray. And when the incident ray falls on the surface, the point at which the incident ray falls, that is the normal. So normal is always perpendicular. It is always 90 degree. So this normal, let's take in this as NM. So NM is our normal for the surface XY. So here we see the path that it should travel, AO. AO being the incident ray, the path that it is supposed to travel is OC. But instead of traveling in the path OC, it travels as the refracted ray OB. So here we see that the ray of light that is traveling, it's traveling towards the normal. Instead of going in this part, it's traveling in this part. So it's bending towards the normal. So if it bends towards the normal, then we understand that the ray of light is falling from a rarer to a denser medium. So that is why when the incident ray is falling on the surface, the refracted ray, instead of going in this direction, it's going towards the normal. So that's because the ray of light is traveling from a rarer to a denser medium. Let me give you another illustration for this. Again, let's take our surface as xy and our incident ray here. Incident ray is the ray of light that falls on the surface separating the two media, and we have our normal nm again. So instead of and the path that it is supposed to go in is OC. So when the incident ray is AO, the path it is supposed to go is OC, but instead of going in the path OC, it goes as OB. So when the ray of light we see over here, the refracted ray becomes OB, the distance between the refracted ray and the normal is increased, which means that the refracted ray is bending away from the normal. So if the refracted ray has to bend away from the normal, that means that the ray of light is passing from an optically denser to an optically rarer medium. I hope this is clear. This is all we have to study in our part 1 of the light chapter in physics. I hope you have understood the concepts. Let us meet again in another educational video. Thank you and happy learning.